Lesson 9 talks about direct variation, and a relationship varies directly, meaning it's a direct variation, varies directly, if it is proportional. And remember, we've talked so far that a relationship is proportional if the graph is a straight line through all of the points and it goes through the origin or the ordered pair 0, 0. Or if it's a table where all of the unit rates can be all of the ratios can be simplified, and that makes all of the unit rates the same. So again, it's proportional if the graph, straight line through the origin, table, if all of the unit rates are equal to each other. If it is not proportional, it is not a direct variation. So to decide if it's a direct variation, you have to first find, is it proportional? And then if a relationship is a direct variation, there is a value k, and you always use the variable k to represent this, which is the constant of proportionality, that is the constant ratio in the relationship. So what I mean by that is there is a constant rate that makes a table proportional. Well, that constant rate is called the constant of proportionality because that's what tells us it is proportional. So the constant unit rate that tells us something is proportional is considered the constant of proportionality, or the k value. In story problems so far, you guys have known how to find the k value because we have found things like price per ounce, and you guys know that the price always goes on the top and the ounce always goes on the bottom. Or miles per gallon, miles goes on top, gallons on the bottom. Sometimes if it's not a story problem with labels, to find the k you need to know that y always goes in the numerator, x in the denominator. So before, when we were talking miles per gallon, your miles was y, your gallons were x. Sometimes in the problem, it gives you what y and x is and what the units are, and so you can double check both ways, but it's always your y over your x. Once you know what your k value is, so once you know what that is equal to, you can write an equation that represents the direct variation relationship. And that equation is always y equals kx. So anytime it tells you in the problems for the homework or in our examples to write an equation, that's what it's looking at, is the y equals kx. Not this one. This is to help you find the constant of proportionality. When it says write an equation, it wants this though. So let's look at examples from the notes. Example 1, and you can find all of the blanks, what the words should be when you look at the notes on Google Classroom. So example 1, this question is asking us, is this a direct variation? And we have to decide, is it a direct variation? And remember, for it to be a direct variation, it has to be proportional. So first we look here, and we know that graph is not proportional because even though it's a straight line, it does not go through the origin. It does not go through 0, 0. So that's non-proportional. Or you can look over on this side and you can say, okay, I want my cost over my number of pizzas. So that would be my y over x. 11 over 1, 19 over 2. Those are not equal to each other. 11 divided by 1 is 11. 19 divided by 2, maybe you don't even know what that is, but you know it's not 11. They are not equal to each other. So these represent a non-proportional relationship, and since it's non-proportional, this is not a direct variation. Okay. Example 2, same type of question. Says there are 2 pounds of cheese, costs $8.40. Show the cost of 1, 2, 3, and 4 pounds of cheese is there a direct variation, and explain. Well, we can fill these in. It gave me this information. For 2 pounds, that would be the price. So for 1 pound, I'd cut it in half, $4.20. For 3, I'd add these two together. That would be $12.60. For 4, I just like to double the 2 amount, $16.80. From there, you would go ahead and do your graph. And again, these decimals make it very hard to graph, so you just have to put them as close as possible to what you think it would be. And then find a straight edge. Once you have your line in there, you can look at this and now decide, okay, is it a direct variation? Meaning, is it proportional? Is it proportional? And here we see it is a straight line through all of the points and through 0, 0, so it is proportional. Or you could check the table. $4.20 divided by 1 is 4.2. Cost divided by weight, 4.2. Cost divided by weight, 4.2. Cost divided by weight is 4.2 every time. So we know, yes, it is a direct variation. And your explanation would be, because it is proportional, and go on, and you would explain it's proportional because it's a straight line through 0, 0, and all of the unit rates are equal. Or you could just do one or the other. You don't have to explain both. The last one, same type of question, and the only thing different then is it says, if it is a direct variation, state the constant of proportionality and write a direct variation equation. So when we look at it, it's just the table, so we have to check the unit rates. Remember, K is always equal to Y over X. If you didn't remember that money always goes in the numerator, you know that's your Y, so that needs to go on the top of the fraction. And I'm just writing out the information that they gave us as fractions forms with Y over X. And I know that 24 divided by 2 is 12. 36 divided by 3 is 12. 48 divided by 4 is 12. And obviously 12 divided by 1 is 12. So all of those are equal, and they all equal 12. So it is a direct variation. And then it says, if so, state the constant of proportionality. And remember that constant of proportionality is our K value. And the constant of proportionality is the constant unit rate that makes it proportional. Well, the constant unit rate that makes it proportional is that 12. So our K value is 12. And the last thing says write a direct variation equation. Remember, that is our equation. We know that K is 12, so we're just going to rewrite it. Y equals 12x. So there's your constant of proportionality and the direct variation equation. Now there's one other type of question on your homework. And here it says, if y equals 18 when x equals 9, find y when x equals 12. And in these types of problems, you have to, the directions tell you to write an equation and then find the missing value. So my direct variation equation, I need to find my k value, and I know k equals y over x, and they tell me that I know when x is 9, y is 18. So I can plug that in. I know y will be 18 if x is 9. From there, I know 18 divided by 9 is 2. So my k value is equal to 2. There we go. The lights came back on for us. Okay, great. Then you write your equation just like before. Y equals kx. So we know y equals kx. That's our equation. And then you can use the equation to figure out the missing number. Find y when x is 12. So y equals 2 times x is 12. And you don't have to write both of these. So y is equal to 24. When x is 12, y is 24. The last one, very similar. The only difference is they rearranged it a little bit on you, trying to trick you. So here, find x when y is 14. That's the part we're trying to find. This is the part that they're telling me I know. If x equals 4 when y is 7. So again, my k value is y over x. And I know y is 7 when x is 4. From here, that's my k value. So I know my equation is y equals 7 over 4x. And then the last thing to do is to find the missing amount. Here it told me y is 14. So I'll have 14 equals 7 over 4 times x. There's a couple ways to solve this problem, but the one that we talked about in class was if it's a coefficient, you always divide. So you divide by 7/4, divide by 7/4. When you take a number and divide it by the same number, those cancel. And this is a complex fraction. So you do 14 over 1 divided by 7 over 4. Then we do our keep, change, flip. And from here you should be able to see that they can simplify. 7 divided by 7 is 1, 14 divided by 7 is 2, multiply straight across, and you would get 8. So when y is 14, x equals 8. Now, I think this is a very difficult lesson, so if you have any questions, make sure you're asking.